Hello everyone. Today we have the honor of hosting a truly remarkable guest, Dr. Walter Scandale. It's not every day that we get to hear from someone whose career has left such a profound mark on the world of physics. I would love to walk you through all his achievements, but there's simply too many to cover in a short introduction. So instead, we are fortunate enough to hear directly from Dr. Scandale himself about his journey and contributions. Before we invite him to speak, allow me to briefly summarize his extraordinary background. Dr. Scandale earned his degree in physics from Sapienza University di Roma, graduating in 1969. He joined CERN in Geneva as an applied physicist in 1972 and continued to serve there with distinction, becoming a senior physicist in 1983 and holding that position until 2009. Throughout his distinguished career, Dr. Scandale has authored 491 peer-reviewed scientific publications, 810 preprints, and 3 books. His work has contributed to major scientific breakthroughs, including the discovery of vector bosons, and he developed innovative beam extraction techniques and pioneered the use of bent crystals and particle accelerators. In recognition of his outstanding contributions, he was awarded the title of Knight of the Order of Merit of the Italian Republic in 2008, one of Italy's highest honors. And now, without further delay, please join me in welcoming to stage Dr. Walter Scandale.
Okay. Good morning, everybody. Just to make a little bit simpler my curriculum, doesn't go as expected. Yeah, okay, thank you. Okay. Just a little 5 points, in 5 points, a little bit of my career. I want to make a little comment on that. First, a disclaimer. I generally prepare for a colloquium a lot of transparencies, and now I see that the audience is very diverse, so I should have had 2 hours to present everything I wanted, but we will stop at any time and then have a discussion later. So my career was started as a physicist in Rome. I was studying quantum mechanics in an accelerator, which at that time was a Prima, and the people in blue are the fundamental person I met at the beginning of my career, which had a profound influence on my formation and idea. Then I was, for a time, computer engineer. At that time, the computers were starting to become a generic tool for many applications. And then I went to CERN, where I was working as an accelerator physicist, essentially for the construction of the super proto-synchrotron, which was the most energetic accelerator at that time. And then it was commuted into a PP bar collider, thanks to the idea of Bruno Tuschek. And this was the fit-through for the UA1 experiment conducted by Rubbia with the help of Simon van der Meer. And this was bringing the activity to a Nobel Prize in '84, so I had the occasion to collaborate with both of them. Then I went to the construction and the optimization of the LHC, which is the largest operating accelerator in the world, and I was active in these particular activities. During this time, I was also the principal advisor of 2 accelerators for hadron therapy, and I will discuss a little bit what this is. And now I'm physicist attached to Imperial College, and I'm leading an experiment which is called UA9. So it's the 9th in the generation of this one, and I'm studying crystal particle interactions. So, okay, so this is the aerial photo of the CERN. So you see the lake of Geneva, the airport of Geneva, and this is the footprint of the various accelerators. The small ones are in this triangular area, and then you have the SPS, which is 60 kilometers long, and then you have the LHC, which is 27 kilometers long, by which there is an enormous number of experiments in high energy physics. The CERN is a laboratory which is devoted to research and discovery of the small component of the cosmos, the microscopic component of the cosmos, but also to education, training, collaboration, technology, and innovation. So you have another overview of the accelerators, which are underground. So here you have the main components of these accelerators, so superconducting magnets, 9,300, so dipoles, quadrupoles, etc. And these are the costs. In this tunnel there are 4 large experiments, here, 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 and here. Atlas, I understand that somebody from Turkey is working and collaborating with this large collaboration, and then there are also medium and small experiments. So this is the tunnel in which the LHC is inserted, and we now go through the exceptional performance of this accelerator. So one is that this is the fastest racetrack in the planet. You have protons which are traveling inside this object, which are very composite inside at this speed, very close to the speed of light, with a very exceptional rate of repetition. So the vacuum chamber in which the particle travels, you have the 2 examples here, is the emptiest space in the solar system. So the vacuum you have to produce here is of the order of 10 million atoms per centimeter cubic, and this is the space, and the inside this vacuum pipes there is 10 times better vacuum than in the sidereal space. This object here is a screen which seems a very simple structure, but in fact it is solving with very complex technological approaches mixed all together in order not to be interfered. It is solving 7 different problems that the particle may have in traveling in this pipe. And this is a masterpiece of engineering and physics, extremely advanced for the time we produced it. The point where the protons collide are 4, and they are the hottest points in the galaxy. So the collision of protons happens in the center of the detectors, and these are simulations of what happens in a collision. And the red particle which you see here are the events which have to be extracted from this mess of information coming all together. And so there is a huge amount of computation necessary to extract the information fast enough in order to sustain the rate of production of events. So you see here simulations, but now we have events of this kind which are produced daily when the accelerator works, which means about 200 days per year. Just to understand what hottest place means is that if you look at the temperature, you translate the energy of a photon in the visible spectrum into temperature, you arrive to 11,600,000 centigrade. When the collision is produced in the volume of the encounter of the two nuclei of hydrogen, you have a release of energy which is 400 billion electron volts, which means 10 to the 17 centigrade. And then you have very complex detectors to observe what the reaction of two protons colliding produces, and you see that the detectors are very large, and in addition they are made from the center to the external part by sector of a specific observation. At the center you have trackers for reconstructing the trajectories. Then you have a detector for the electromagnetic energy. You have a detector for the hadronic energy. And then you have a series of detectors to observe the muons that are produced during the collisions. And this kind of detector is extremely high volume, of an extremely high volume, which is about similar to a building of 10 floors. Then to treat the data which are produced by the accelerator, you need a huge amount of computing power, and so the concept of grid has been invented, by which an enormous number of computers, including yours, if you give the approval, are used continuously to elaborate the information which is produced by the detectors. And the number of computers which are linked into the grids is of the order of 500 computers displays located in the entire planet. Sorry, okay. This is essentially the entire geography of the accelerators and why this CERN has been created. The CERN has been created by the UNESCO in 1954 because the effort, economical effort to sustain the such a complex of investment was unsustainable by each member state, and so there was the CERN was created to join the efforts, and now the CERN is the leader in high energy physics, and just as a byproduct of the activity at CERN, there is the web. I will discuss a little bit later if we have time. And this is being created just to understand the nature of the matter and forces, and to clarify how the universe was evolving at the beginning of its Big Bang, just for the human honor and the mankind ability. Modern big science is founded on international cooperation, high-level education training, technological drive and innovation in directions which cannot be predicted so easily, and so this is what is creating essentially a lot of effort to make attempts to find the best way in which the innovation should be produced. But the process is extremely interesting also for politicians, because you have the investment in fundamental science is producing an enormous benefit in terms of byproduct. Okay, CERN is the member state of CERN are listed here, and there is a special list of countries which are in a waiting list, so they have a special, a partial association to CERN, but they are in waiting list to become member states, and Turkey is in this list. The cost of CERN is of the order of 1.4 billion Swiss francs, so the budget is in Swiss francs. The Swiss francs is a little bit higher than euro, and the distribution of the investment is given by this pie plot, but just to be more concrete, you see that the cost for the member state is about 1 coffee per inhabitant. So it is, in terms of investment in fundamental science, this is enormous, but for the society is not so large. So the governance is shared between the member states. You have a council which is to which the member states take part, and you have observers, and then you have advice policy committee and various boards to define the priorities in the experiments, and this is the staff which is participating to serve. Okay, what is the science the CERN is looking for, and what we have understood in the long quest of interpreting the microscopic world. So we have what is called the standard model of the microscopic world, which is the interrelation of the constituent and of the forces acting in between the elementary constituent. Elementary means that at the present stage we believe that this elementary constituent can no longer be segmented in fragments. So we have the quarks, which are the constituent of the nuclear matter and of the nuclei, and the leptons, which are the constituent of the surrounding particle, which compose the atoms, so the electrons, but also there are two other families of heavier electrons, which are called mu and tau, which are a mystery why they exist, but we know that there are only 3 families of this type of constituent, and then we have neutrinos, which are associated to each of these leptons, and which are also a field of research, intensive research, because the mutual interactions of the neutrinos are not fully understood. We have questions which are still unsolved. What is the mass? We know what Newton and Einstein have said about it, but we don't have a clear view of the mass yet. Why the nature is favoring matter and not antimatter? This is a mystery, because when you create matter, you also create antimatter, and when you destroy matter, you destroy antimatter, but the universe exists and it is made only of matter. So where is gone the antimatter which was created together with the existing matter is a mystery. Then we have yet unclear understanding of the Big Bang. So what matter and forces are is clear in the present world, but we don't know what they were in the first instant of the universe, and we don't know how they were acting in order to produce all the phenomena which are interesting, the initial moment of the Big Bang, and in particular the inflation period in which the world was expanding at a speed which is inconceivable and which has uniformized the distribution of the various components created by the Big Bang. Sorry, I was changing without, okay. We have the enigma that the present science is giving account of 4% of the matter we observe in the universe, while 96% is not understood at all, and this is made of what is called the dark mass and the dark energy. Then we believe that there are more than 4 dimensions, and we don't know if this is true, so it's a question mark. And the super world is a way to explain why there is this extra quantity of energy and matter which is unexplained. Okay, this you will learn, those of you who are in the high school and will do physics and start continuing physics, they will learn about this if they will become specialized in high energy physics. And maybe they will contribute to solve some of this enigma. So what are the tools used in this quest of the understanding of the microscopic world? The tools are essentially the accelerator. The understanding of high energy physics started with cosmic rays, but it was structured in a correct manner and in a largely understandable form only when the accelerator became available, and the accelerators are a very complex machine which need large investment, but also a large technological effort and innovation. The detectors are the instrument by which the collision of particles between them becomes visible, and detectors are also gigantic instruments to record the trajectories and the energies of the particles, and they also are technologically masterpiece of the humankind. And then, last but not least, the computing power, because to collect, interpret, and store all the information produced in the collisions by the detectors, you need an extremely powerful amount of computers. So, okay, I think we can skip this because I want to, these are just photos of the various installation of LHC. So CERN, as I said, is trying to answer the question about the cosmos, the nature and the mechanism by which the cosmos works. And in this quest, CERN stimulated advances in technology which are really unpredictable. I will show you in a moment some of them. And it is an excellent place to prepare scientists and engineers for the tomorrow's activities, even if they have a partial contact in their life, scientific life with CERN. We have at least 1/2 of the students which goes around doing other activities, including, for instance, activities in stock exchange, etc., which are a profit of the understanding of mathematics and law of nature in CERN. And this brings also nations together through science. So the benefit of CERN is very large. Margaret Thatcher was a lady not so prone to spend money in useless activities, was so convinced of this that she expressed it herself in a very positive way about CERN and his activity. So, okay, we can also skip this because I want to show you a little bit more on the technologies which are produced by the fundamental activities at CERN. So, first of all, we discussed of the accelerator as which are the fundamental tool to produce the interactions one wants to study. So the invention of accelerators started at the beginning of last century. So you have here 2 examples of accelerator produced in the 20s of last century. But if you look at the number of accelerators which are in use today, you see there are 30,000. And if you look at what they are used for, you see that the activity of research in nuclear and particle physics is an extreme minority. So the main activities of accelerators are industrial, medical, and research of non-nuclear or atomic and molecular kind. So the starting technology, which was fundamental to understand the micro world, has become useful for so many activities, and this was totally unpredictable when the accelerator started to be studied. Okay. This is an activity which I took part in the last part of my career. So the accelerators are used for the cancer treatment. So this was an idea which became clear around the middle of last century, but the optimization of the radiotherapy took a certain number of decades, and now you have a lot of tools to treat cancer, which are based on ionized radiation, which are used to damage the DNA of the tumor cell, or they create indirect damage to the cell, cancer cell. So you can use electrons accelerated by electron accelerators to irradiate the patient, but you can also use hadrons. Hadrons are the heavier particles which produce nuclear forces. The electrons produce only electromagnetic forces, and the therapy with protons or carbon ions has been developed in the second half of last century, and nowadays it is used in many hospitals in the world. The reason why this process has been used for the cancer treatment is expressed in this graph, where you have the release of energy as a function of the distance, of the depth of penetration of the particles into the body. So the electrons are releasing most of the energy in a very short space, and the same is for photons, which have a long tails of irradiation. So you can irradiate only cells which are superficial. If you want to irradiate cells in the deep of the body, you can use hadrons, which have a curve of energy loss studied by a physicist called, the name of which is Bragg. The Bragg peak is that the release of the energy of the hadrons happen when the hadrons are practically at rest. So it is very well localized at a certain depth of the penetration, and this depth depends on the energy of the incoming hadron. So this is why this kind of therapy has been introduced, and as you can see from this graph, it is totally driven by science, because this kind of process have been studied during the first half of the last century for reasons related to the study of the particle interactions and to understand what are the trajectories of the particles in the detector and so on. So the application, the translation of this knowledge to medicine is something which could behave only because of the deep understanding of the process of nature, of the interaction of high energy particles with matter. Okay. There is now 1,200 accelerators in the world working with the concept of either photon or electron or hadron therapy. Okay. We go to the second element, which is has medical applications, set of knowledge which has medical applications, which comes from high energy physics, which is the detection of the image of the inner body. So this is also a process which has became possible because of the deep profound development of detectors of high energy physics, and it has an application which is really extremely important for the various diagnostics, medical diagnostics, which are produced yearly in the world. So the PET is a tomography of the inner body based on the emission of positrons. So the body is a product which is unstable and produces positrons, is injected in the body, and it has a vector that brings the molecule of the product into the cancer area. So this is obviously an important series of development of the biology. But then you have the decay of the product, and you have a series of detectors that can observe and track the origin of the positron which are decaying from the injected product, and this is a mechanism to identify where the cancer cells are located into the body. And you see you have a simultaneous emission of particles in the two directions, and the electronics of the system is able to identify the exact point from where the decay has been originated. All this is clearly possible because of the development of the tracking method in high energy physics. Okay, you have other similar technologies based on other possibilities, which are then, in this case, linked together, and you have a higher, larger possibility of investigation of the body. There is something which... Okay. And we go to a second kind of technological and physical understanding of the nature, which has been driven by high energy physics, and we will see also the application of this in a moment. So let's first discuss of the process. The process is the cooling of noble gas. This was a subject of intense investigation at the beginning of the last century, and the success was due to many persons. This is a prominent scientist in these activities, and when the cooling was applied to something different from helium and noble gas, for instance to mercury, it was observed that there was an enormous drop of the resistance of the current flowing in a superconducting material. So this was a discovery which was certainly assigned the Nobel Prize, but to have applications it took a certain time. First, to understand the detailed process, it was extremely difficult, and the quasi-understanding of the process was realized in the middle of last century by three scientists, which founded a theory on quantum mechanics. This is also Nobel Prize. Application to accelerator. So, current produces a magnetic field, and the magnetic field allows to deviate charged particles. So the point is to produce cables, wires, cables, and magnets based on the superconductivity. So you have an intense effort which was pushed up to the point it was finally optimized for the LHC, where the cables were able to transport with a reduced resistance a current of 14,000 amps. So this is the equivalent of 10 power lines distributing power current in a continent such as Europe. So the superconducting cables are the inner part of the magnets. They produce current which circulate in coils, and the current produces a field which allows to bend the particle and make them circulating around a circle. Without such high current, you cannot produce high magnets, and then the circle of the accelerator should be much larger. So if you gain a factor of 1,000 in current, you gain a factor of 1,000 in you reduce the dimension of the accelerator by a factor of 1,000. So this made possible the construction of LHC. And to arrive to this understanding and technological development, it took almost a century. Now, other applications of the superconducting current are the high-speed train, which levitate, and so there is no friction with the trails, and you have some of these trains which are operating in the East world, in Japan, in China, in Germany, and they are able to arrive to speeds of 600 kilometers per hour because of the ability to avoid the friction between the trains and the wheels. So this is an extremely interesting application, which is unfortunately slow in becoming common because of the investment. There is a huge investment in the ordinary trades, and then you have to develop the correct economy to make a general applications of this idea. But then again, you come back to the body investigation. The magnetic resonance imaging is exactly founded on the fact that the body is submitted to a magnetic field, and because of the rotation of the spin of the particles, elementary particles, especially water, which is composing the body, you can have an inner insight. You see here an inner insight of a head of the body by exploiting magnetic fields, and if you do the fields which you produce the field with a superconducting magnet, you can have a faster analysis of the inner part of the body. And we come to the third chapter of the applications, the World Wide Web. So this gentleman was a postdoc fellow at Bern. At the time, there were the large collaborations of the LAP accelerator, The left is the machine which was in the LHC tunnel before LHC. And there was a problem of transmitting the information between the collaborations which were spread around the world. So there were a large number of conferences to exchange information. And this gentleman had the idea of producing a protocol to transmit through internet, which was developed already well in advance with respect to the World Wide Web. This protocol was able to transfer not only words but also drawings between the various computers distributed in the world. And so it was possible to speed up the check of the compatibility of the various parts of the detectors which were built for lab. So the idea was considered a sort of game, useless, and the importance of web was discovered after the first couple of years by seeing how powerful was the method, and nowadays it is not necessary to insist on the importance of the web for the human activities. Okay. This is the internet activity today, mostly driven by the large use of web by the humankind. The grid of computers, which I already mentioned, is also a master idea in computer science, which is not yet exploited well enough by the entire society. So you can see from the few data which I wrote here, which is the powerful ability of treating data by a grid of computers. And you see that the amount of data produced by LHC is so large that you see in 1 year it is producing 1% of the total amount of information produced during the entire existence of the mankind. So the grid is able to digest and streamline all this information. So this is another impressive byproduct of high energy physics, which is still waiting for a full exploitation. Okay, I think, sorry. Okay, this is still the same concept. I want just to explain you the last two points of the technological points which are important for your life and which are produced by either basic science or by technological application of it for high energy physics. So the relativity was invented by Einstein to explain a little bit better the gravitational force, which was, a little bit non-scientific, including by the admission of Newton, who invented it before Einstein. So because of the way the force is transmitted. So by transferring to the geometry of the space-time the effect of the gravitational force, Einstein produced this magnificent architecture of the science, which is the relativity, general relativity. Now, this is a totally theoretical science, but the localization by GPS is founded on the corrections which have to be applied because of general relativity. Otherwise, you cannot in no way localize an object in the Earth. You should have fraction of the theory of the relativity into the algorithm which is producing the localization. And your cell telephone works and is based on the theoretical architecture that Maxwell did of the electromagnetic theory in the middle of the 19th century. So these were 4 equations which were produced by collecting the experimental data on electromagnetism already known at that time. They are sort of magic equations because they are such that they already obey to the law of relativity without any correction or modifications, but this basic fundamental science is the way by which, is the basis by which the cell telephone can work. So the fundamental research is not only for understanding the cosmos and the microscopic world, but also, as I hope I convinced you, that it is a driving force for innovation. I think I can just sweep a few images. Still have a couple of minutes. So this is the history of the Big Bang. I don't want to go into the detail because it is almost ununderstandable without a large knowledge of physics and mathematics, but this reconstruction is based on astrophysical, but mostly on high energy physics or particle physics knowledge. Sorry, I think there is something. Okay. So in the scale of length, in the scale of time, the fundamental physics is trying to explain the early instance of the universe. Early means that this is a fraction of second. So you see where we are going with high energy physics in the reconstruction of the history of the Big Bang, while the astronomy and the astrophysics is explaining the large distances and the evolution we are expecting for the universe. This, I think, I don't have to insist that the Standard Model is producing a complete understanding of the microscopic world, and the addition of the Higgs particle is completing the Standard Model. Standard Model is the word which is objected because it will become the standard theory. And then the Higgs, which was the missing part of the Standard Model, explained the masses which were not explained enough. before, I think we arrived to the end. The observation of the universe, far universe with telescope, and the understanding with astrophysics, and that the understanding of the called the astroparticles coming from the far universe is opening a new science. The gravitational waves are opening new way of observing the far universe, and so this is completing the understanding of our world in the large scale, which is already the origin of two mysteries, which is the dark matter. The dark matter was seen by the gravitational effect in the galaxies, which are rotating too fast in order to be stable. And so there is a postulate that there is a dark matter here. There is a reconstruction of the density of the dark matter. The red is more dense, the blue is less dense, which is in the galaxies, in order to explain why the observation at the scale of the galaxies were contradictory. And then you have the other outcome of the astronomy and astrophysics is the dark energy, the gravitational, the theory of the general relativity was doubtful in predicting the evolution of the universe in the very distant time beyond us, and now the observations on the galaxies are saying that the line, the yellow line, which was the stability with the universe quasi-stable, is not true. We are seeing that the speed of the galaxies, one with respect to the other, is too fast. We don't know why it is like this. This is another mystery for those who would go for astrophysics. It's one of the mysteries they have to face. Okay. So you see in the today's understanding of science, we can explain 4% of what it has been observed with various tools. The dark matter is called the dark because we don't understand what it is, and it is observed through gravitational effect of the galaxies, and the dark energy is called dark because we don't know which energy is it, but we know that there is an energy which is pushing the galaxies one far distant from the other at a speed which is much faster than predicted, and this is pushed by this dark energy. And if you make the balance of the energy of the world, you see that only 4% is visible and understandable, and the rest is not. Okay. Thank you. So I'm sorry, I was a little bit fast just because I wanted to show you the entire.
Thank you for your valuable speech. Now we will move on with the question and answer session. Thank you. We may take you to the chair in your side.
Okay. Thank you very much, first of all, for your presentation and for coming all this way to visit us here in Turkey. My question was about your opinions on our understanding of the universe. Do you think humans will ever be able to completely grasp how our universe works and its laws? I'm trying to ask if there would be an end to science. I'd like to know your opinions on that.
I have, the audio is very bad for me. I cannot hear you very well because there is a sort of echo.
Is it better this way? I was curious about your opinions on our understanding of our universe. Do you think humans will ever be able to grasp completely how this universe works, its laws, and will there be an end to science?
There is not much we can do today. I don't think we can do much to solve the unknown I have pointed out during my talk without a huge effort in the theoretical understanding and in the technological investment. So this is for your generation to find the solutions to the question mark which we were unable to solve up to now. So I cannot say more than what I said. This is our present understanding of the universe, and we can only point out the unknowns and not solve them without new tools and new people. So you have a future in this field, a long future.
First of all, thank you very much for coming. My question is about tachyons. There are many different options about tachyons. I'm curious about your opinion. Do you think they could exist? If so, what can we do to discover them?
I'm sorry, but you have to repeat without the loudspeaker because there is, at this point there is an echo. I was able to understand what you're asking.
It's about tachyons.
Yes.
Do you think they could exist? If so, what can we do to discover them?
Okay, I don't think you are speaking of the vacuum in an accelerator, but you are speaking of the vacuum in the quantum mechanics. I guess you are speaking of this. I'm right or not? Which vacuum you intend to, because you have the vacuum, absence of molecule in the air, in a space, but you have also the quantum mechanics vacuum, which is the full of energy and which we suppose today is the origin of the Big Bang. A fluctuation of the energy in the vacuum produced the Big Bang. So the Big Bang is potentially an event which can be repeated in the history of the universe. Is that what you were...
Tachyonic particles, is that? I think our definite is asking about tachyonic particles.
So this is what I was saying. The vacuum of particles is full of energy. this is the quantum mechanic viewpoint today. So the vacuum do not exist. This is the present view of the microscopic world. And the vacuum is full of events which persist in a time which is shorter than the indetermination principle, and therefore it is full of particles and of energies. And this is what produced the Big Bang, at least in our present explanation of the Big Bang. Okay. So also there you can have an enormous material of study, but especially theoretical, because there is no hope to do an experiment in which we can repeat the Big Bang. This is outside the humankind possibilities. Okay.
Şurada soru var. Bu da var. Mikrofonsuz zaten tercih ediyor hocamız. Kalkıp söyleyebilirsiniz.
I would first of all thank you for coming here today and giving us this inspiring speech. My question will be more about the structure of the giant particle accelerator. How do the workers and the scientists in CERN maintain and fix issues in this giant particle accelerator? I believe that when you explain there are the largest and most complex structures in this accelerator, and there are many types of devices consisting in it, it may be a hefty task to locate any problems within the structures and fix it. So if you have any knowledge, may I?
So you want to know about the complexity of accelerators, if I understand well,
Both
and
complexity and how they could fix
and how
problems.
we check that everything is compatible in order to make the accelerator working. Okay, so this is in principle, in view of the number of actions you have to do in a large accelerator, the probability of something wrong is 1. But I don't know if we are lucky or what, but in fact at the end the accelerator works. You are probably aware that the LHC at the beginning of his life had a terrible accident which destroyed, okay, you saw there are many magnets in the LHC, but the mishap was extremely large, and there was one, I think it was more than 10% of the accelerator which was destroyed by a series of events which were involving a leakage of the refrigerating gas, which is helium. And the reason was reconstructed, and the reason was, in effect, a very improbable event happening, which was a bad soldering of one of the connections in which the current is flowing, and the fault was not complete, but only partial, so there was an arc, electric arc, which was generated, and the electric arc produced a huge rise of temperature, which in a few fraction of a second destroyed shielding, which was 4 centimeters, and this produced leakage of the helium, which was very, very rapid, and the shock, the mechanical shock, destroyed 1/10 of the magnets. So this was something which is one of the worst events, probably it is the worst event produced accidentally in the history of the accelerators. And it was due to the number of soldering, electric soldering is, I think, 10,000. No, sorry, 100,000. And one of these was not well done, and in a very strange way. But in fact, all the other accidents in the accelerator were produced by human errors. For instance, an accelerator in Russia was destroyed because the team in charge in the night was drinking too much. So they were not following well what was happening, and there was a fire, very destructive. So, but in general, there is a huge effort to control the quality of all the technical feature of an accelerator, because an accelerator is a really complex mechanism which is for which it is very important to apply a security set of rules, very strict and very strong. In fact, they work. Most of them work without problems. Yes. I don't know who has to speak, but go ahead. There were two ends very close to each other. Okay, go.
First of all, I'm sorry for misunderstanding, and thank you for coming here today, for giving us a speech. It was actually had a lot of information on it. And my question isn't only about science, because you're an experienced scientist, and I want to ask you about your opinion about the balance between art and science. Do you think art is for science, or science is for art, or they are equal?
Okay. In CERN, there is a center for integrating art and science, because they are, I would say, more complementary than in an opposite position. The main difference with science is that science is the product of an intellectual effort which is implying the actors for the lifetime. Art is the same, more or less, but is due to an ability which is essentially related to the way the artist is able to express his interiority. In science, you have to express your understanding and your knowledge. So you have to have a very strong preparation. You have to study a lot, and you have to know what you are doing. And I would say, I mentioned this to the students which were at the beginning with me. Science is an activity in which you have to accept failure. Failure is about 90% of the activity of science. So you throw out 90% of your work continuously because you are trying and it doesn't work. Sometimes you don't have the tools, mathematical tools, and you have to invent them, and this takes time. You have to, for instance, the general relativity of Einstein was taking the knowledge of a mathematician 1 century before Einstein, who was studying the non-Euclidean geometry, so the geometry in which the parallels are encountering somewhere. They are not always distant from each other. They are not encountering at the infinity, but they are encountering somewhere. So it was a geometry totally theoretical, and without it, it was impossible to create the general relativity. So you see that the interplay of the various sciences is very strong, and it is individual because it's the individual effort who is the basis for the creativity in science. And then you have also the individual effort which is implemented by the common effort. You need interplay of various minds and various opinions in order to progress. And there is only one at the end who finds the last step. But you have therefore you have the individual knowledge and the common work and effort, which have an interplay. In art is, okay, you have also something which is similar, but the art is rather individualist. Science cannot be only individualist. The last step is individual, but the preparatory steps, which are as fundamental as the last one, are a common effort.
Thank you.
I hope I answered. You asked a very complicated question.